We're going to sketch the graph of a function that is continuous on 1, 5 and has an absolute maximum at 2, an absolute minimum at 5, and 4 is a critical number, but there is no local maximum and minimum there. So the important thing in this example is that 4 is a critical number, but there is no local maximum and minimum there. And the thing is that if the function has derivative at that point, for example, then the derivative must not exist, because if it exists, then it means it should be 0. There is the tangent line should be horizontal, and in that case, we will have a local maximum or minimum. So in order that there is no local maximum and minimum there at 4, but it is still as a critical number, it means the derivative does not exist. For example, if a tangent line is vertical, like in this example, the tangent line at 4 is a vertical line, so the derivative is not a number, and evidently there is no maximum nor minimum at 4, because around 4, there is to the right and to the left, there are images that are bigger and smaller than the image at 4, so it's not a local nor a minimum. So with that, we solve that part, and we can see that at 5 we have these lowest point in the whole graph, and at 2 we have the highest point in all the graph, and in this case we have drawn a non-differentiable curve at the point 2, but that's not a problem. Remember, the only request is that the function is continuous on y5, and this is the case. There's no discontinuities or jumps at any point. And at 2 we have the highest point in the graph of the function. It's also local maximum, but is as requested the absolute maximum value. And at 5 we have here the absolute minimum. And at 4 we don't have maximum or minimum, and it's a critical point because the derivative does not exist at that point. So this is a solution to the given problem.